Welcome to the lair of the Batty Boffin.
Hi there Batty fans, a little bit more about equations with the Batty Boffin here. Now if you've seen earlier videos you've probably seen these kind of machines as a way of solving linear equations. If you want some of these yourself, I've got some downloadable pre-printed ones available at www.battyboffin.co.uk. Pop along there and click on downloads and you'll find some printables with 2-stage, 3-stage and 4-stage machines if you are too lazy to draw them yourself. We're using some 3-stage machines today to do the slightly more complex ones. Things like this that I've got written in green. Now we call this a 3-stage problem because there are 3 things that we're doing. We've got an add 2, we've got a times by 3 and we've got a take away 4. Okay? And the machine here helps us to sort out which way we undo them when we're trying to get at the x. Now, if I gave you a value for x, hopefully you could use your BIDMAS or BODMAS or PEMDAS, whatever you call it, the order of operations, to work out what things you would do to that x first if I told you a value of x. Let's say I told you that x was 10. Hopefully you would know that you do the brackets first, which means that you do the add 2 first. Then, because multiplies, we do the times by 3, and then adds and subtracts come last, so then we'd do that take away 4. That's the order in which we would kind of wrap up the x if we were putting these layers. And this machine will help us to take the layers off in the right order. So, if you've seen the previous ones, you will know how to do this, but just as a quick recap, here we go. We start off with x at the far end. And in the first box we put the first process, which is add 2. Which, when we come out of the box, gives us x plus 2. Right, can you pause the video now and fill in the second process here and what comes out, and the third process here and what comes out. And here's a clue. The stuff that comes out at the end should be that on the left hand side. So pause the video and see if you can fill in the rest of this top level of the machine now. Right, the top level of the machine should look like this. We came out of the first box with an x plus 2, and the next thing we did was times it by 3, which gives us 3 lots of x plus 2. You could put the times 3 at the end if you wanted, it wouldn't make any difference. I've put mine at the beginning to try and make it look like that. And then the last thing we do is the take away 4, so when you take away 4 from that expression, we get this thing we were looking for, the left hand side. Our equation tells us that that is equal to 23. So if you're using the pre-printed boxes, you should always end up with the right hand side being basically your equation, just kind of written vertically instead of horizontally. You can always draw these boxes yourself, of course, if you haven't got the pre-printed ones. We're now going to put that 23 back into the machine, running backwards, and get the answer out the end. So when we put 23 into the machine, we find that the thing we did last when we're creating our expression is the thing we do first when we're taking the layers off. Think of pass the parcel. When you're doing a pass the parcel and you're building the present up, you start with the present and you put the layers around it. And the last layer you put on is the first layer you take off. So that's what we're doing here. And to get rid of a minus 4, we do an add 4. So that's like undoing the wrapping. 23 add 4 is 27. Now, instead of a times by 3, well, I'll let you finish that off. Instead of a times by 3, what goes in there? Process the number, have it come out the end. Put the opposite process in there, come out with the answer at the end. Have a go with that. So here's what your machine should look like. Our 27 gets put into a divide by 3 machine, comes out as 9, which gets put into a take away 2 machine and comes out as 7. X equals 7. That was our answer. And I have to say, looking at that, you couldn't just kind of see 7 in that. Some of the simpler equations, you can just look at them and see the answer, but by the time they get up to this level of complexity, you can't look at that and see the answer. But we can check that it's true. Put 7 in there and see what happens. 7 plus 2, that's a 9. Multiply by 3, 27, take away 4, 23. Yep, perfect. Okay, I'm going to wipe down the board and then I'm going to put another one of these up here and you're going to fill in your machine. See you in a minute. Right, here's one for you to have a go at. It's another stage 3. We've got a times by 2 and an add 7 and a times by 4. So starting off with x at that end, work out what is the closest thing into the x. If you're starting off with the x, which layers would you wrap it in first? First layer goes there, the inner layer, then the middle layer, then the outer layer. You should end up with the expression on the left, just here, equal to 32, and then run that backwards to get the answer. Have a go with that now. Right, let's work through that together. The innermost layer is the times by 2. We've got these things in the brackets to do, and BIDMAS, BODMAS, PEMDAS tells us that multiplies and divides are done before adds and subtracts. So we've got times by 2, giving us a 2x. I'm going to fill in the rest of this speeded up, I think. Right, hopefully you've got that on your top row. And then when we put this 32 back the other way, we should end up with the answer. Here it is, speeded up again. Okay, 1 divided by 2. Yep, that's fine. You don't have to have whole numbers for these things on here. This one you could write either as a decimal or as a fraction. I'm going to write it as a fraction. X is a half, or you could have 0.5 obviously. 2 lots of a half, that's 1. Add on 7, that's 8. Times it by 4, we get 32. Okay, one more example for you to do. Right, this one has got a divide in it. Okay, that over 5 can be regarded as a divide by 5. So, see how you get on with this one, and then we'll go through it together in a minute. So starting with that x and working our way out, the order of the operations, the closest one is that times by 3, and then it's the take away 4, and then it's the divide by 5. It's not the divide first, although multiplies and divides come before adds and subtracts, because this, with that line going underneath the whole expression, effectively means that top bit is in brackets. Yep, it would be a different thing if that line only went under the 3x, that would be a different thing. So effectively the whole of that top is in brackets. So the order of operations is the times by 3, then the take away 4, then the divided by 5. So here's the top line speeded up. And that equals 1. So on the right hand side we've got our equation. And running that backwards we get this. There, the answer's 3. Did you get that? I hope so. Right, that's enough of the 3-layer ones. As I said in the downloadable sheets, you've got 2-layer, 3-layer and 4-layer problems here with the 4-box machines. You can have this as many as you like, of course. But what I'm going to do in the next video is show you exactly the same maths, but laid out in a slightly different way that frankly doesn't take quite so much room. This is great for showing you the order in which we do things, how we pack it up. We start off with x and we pack it up in one direction, and when we unwrap it, we go in the opposite direction, and the things are reversed. So where it was a take away 3, or sorry, take away 4, we do an add 4, where it's a times by 3, we do a divide by 3 to kind of undo the thing. So next video we're going to do the same kind of problems, but we're going to be setting it out in the more kind of formal algebraic style that you might have seen in textbooks. But this is great for knowing why we're doing what we're doing. See you in the next video. Bye for now, Batty fans.